In this video we're going to take a look at the IRCWare challenge on HackTheBox. It's an easy reversing challenge, and the description says, during a routine check on our servers we found this suspicious binary. Although when analysing it we couldn't get it to do anything. We assume it's dead malware, but maybe something interesting can still be extracted from it. So we want to download the file. We'll take a copy of this into our local directory. There's a folder in here as well, but it just seems to be the same binary inside it, so I'm just going to leave that. And let's go and do some basic file checks. So we'll begin by checking the file type and see that it's a 64-bit executable, so let's make it executable as well so that we can run it. And let's have a look, see if there's any interesting strings in there. Straight away we can see that we have some IRC commands, so assigning a nickname, joining a room, and then sending some private messages with some functions here at the end. We can see one mentioning flag and pass as well, and then obviously we're going to require a password as well. So let's try and run the program, see what happens. And we get this message, exception abort, which we just saw in the strings as well, so we might want to try and run it with ltrace, and we don't get anything else useful. So we could open it up in GDB and try and debug it and see what's actually going on there, but let's create a new project in ghidra and we'll go and have a look at the assembly and decompiled code. So once this is opened up, we can go and have a look at the functions. We don't have a main function because the binary has been stripped, so we can go and have a look at the entry function and see what's going to happen when the program loads. So let's have a flick through the code before we dig into any of it too deeply. We have a syscall here at the beginning. We can see that this looks like the nickname variable here, and we can see that the nick IRCWare underscore 0000 is defined. And then we have some of our IRC commands here as well to define the user to join the secret room. And if we go into this first function call, we have some syscalls. We have the .data section being assigned a value of 29 in hex. Let's go back. And then we have a condition here if the ivar1, which is going to be returned from that previous function, is greater than -1. So if it's not negative, then it's going to run through some additional functions. So whenever I was trying to solve this challenge, I've spent quite a bit of time trying to work through and see what a lot of this code was doing, but not all of the code is relevant to us solving the challenge. So we can see here that this function is called 3 times. It doesn't appear to do too much, although we do have a write operation at the end, but we'll go through and have a look at those syscalls in a little more detail. And we get this function is called 3 times, and then we have a do while loop, which is going to call these additional functions. Again, not too much happening in this one. We have a syscall, so we'll go and work out what that's doing later. And then we have our main functionality here. So there is quite a lot of code going on in here. Again, we don't need to understand what all of it's doing, and we see some sections of code which are being repeated, which aren't necessarily doing too much or doing much that we need to understand to solve the challenge anyway. So we can see here this is where we have references to our flag function and the password entry and stuff like that. So it's obviously going to be of importance to us. Here we have an accepted and rejected. So if we're trying to reverse engineer something and there's a lot of code, we want to go to our end goal. So our end goal we know is going to be to have our password accepted and retrieve this flag. So that's where we want to start off and work our way backwards and find out what conditions do we need to meet in order to get to that stage. But before we dig in too much into this main function, let's go back, and because there is quite a lot going on in the program, we'll go back and try and add some comments in, work out what these syscalls are doing, and name some of the functions just to make it a bit easier to read. So let's go and open up a Linux syscalls table, and we can go and map some of these system calls to whatever values in the RAX register whenever the syscall occurs. So we have a syscall here right at the beginning, and we can see that before the syscall operation we have 13E in hex being placed into the RAX, so that's 318. So if we go back here and search for 318, we'll see that that equals sysgetRandom, and then our registers which are being used here, the RDI, the RSI, and the RDX. So we could go back as well if we want to have a look and see in our RDI we have 0000 is being placed in there. So that's where it's going to write to, and then it's going to read in the count here is going to be in the RSI, so that's 4, so it's going to read in 4 random bytes into these zeros here. So essentially what's going to happen here is the nickname is going to be defined, right? It's going to get 4 random values to insert at the end of the nickname. So we could go ahead here, and if we just hit the semicolon here, we can add a comment and say this is random assign 4 bytes to nickname. Although I guess some of the occurrence is happening here as well, but that's fine. So let's go through and see what's happening next. We have this function call, and in here we have 2 syscalls as well. And we can see before our first syscall we have 29 being placed into the RAX. That's 41. So we'll go and have a look now at the 41. Oops, not that one. Syssocket. Okay, so this one's opening a socket, and the parameters are the family, the type, and the protocol, which we don't really need to worry about too much. Let's have a look at what the next syscall is. And the EAX this time has 2A, which is 42. So let's go and check, and that's right down below it. So we have the sysconnect. So we're opening the socket, and then we're making a connection as well. So whereabouts is it connecting? Well, we have our IP and our port, which are being pushed here, but let's have a look at that a little bit later. Let's just map out some of these syscalls first of all. So we'll go ahead and call this one the socket open, and then the next one is connect. And then we can go back and see what's happening with this function here. So we have a syscall at the end of this as well. So there's quite a lot going on with this loop. But if we just go down to the syscall, and we can see here that 1 is placed into the RAX this time. So without really needing to check it, we can find out that that's a write call. And again, I didn't really look too much at what was going on with this function in terms of trying to decode what these loops are doing and what it's actually printing. So I'm just going to go back here, we'll rename this, hit L to rename this, and I'll just call this write, for now, write wrapper. We can, once we do some dynamic analysis on this with GDB, we could work out what's happening and then go and update our naming if need be. And then we have a couple of other functions to look at here. We have some syscalls at the end as well. So we have a syscall here which is 3C. So we can go back and have a look for that one as well. That is 60, and that's our exit. So it's going to exit at the end, which I guess would be the second syscall there. So before that, we also have the 1 is put into the EAX. So there's a write call, and there's a sys, which is writing the exception abort as well. So we could just say here as well, write exception abort, and then at the end we exit. So let's take a look as well these functions. This one didn't appear to do too much. We have a syscall here which is, where's the EAX? It has 2A in the EAX this time, which is 42, okay. Which we had as well. What was 42? Sysconnect, okay. So we have another connect here. Which will also update, I guess, the function name here as well, because it doesn't appear to do too much there. So we'll call this connect, and then we have our main functionality. So here I'm just going to go back and I'll just call this IRCBot, and there we go. So we've kind of put together most of our, did I not rename this function? This was the socket opening as well. Okay, so we'll rename that as well. Establish connection. Alright, cool. So before we go into the IRCBot functionality, let's find out where the connection is going. So we know that we had the IP address and the port in here, but the format that it's in doesn't just convert for us. So we can go and have a look here with the convert, but Ghidra doesn't have the option to convert this into an IP address. And if we go here with the decimal as well, we're not going to get the right port number because of the little endian format. So we need to go and convert this elsewhere. So we'll deal with the IP address first. I'm going to take a copy of this. You can probably guess what this is going to be, but just so we know how we can deal with this, I'm going to go to CyberChef. You can just Google convert hex to IP address or something as well, but CyberChef I like, although it's a little bit slow for some things. It has a lot of different tools and functions in here, so it's kind of handy if you might need to swap between a lot of different formats or use some different tools in a CTF or something like that. So let's have a look here. If we search for IP, we have here change IP format, and it says convert IP address from one format to another, for example, and you can see it converts from the dotted decimal format to hex. So let's take a copy of that, and we want to convert it in this case from hex to dotted decimal, which is awesome, but that doesn't look right. Let's go here and add another 0, and that's looking a bit better. But you'll see that it's in reverse order because of the little endian format. So we can also go here and say swap endianness, and we can insert that at the beginning, and now we have our IP address. So you could probably guess that it was going to be our local host IP address because this is a local challenge. There's no server to connect to. The only other thing we need then is the port. So the port here, let's take a copy of that, and I'll paste this in here. Let's get rid of, I'll turn this off. I'll get rid of our change IP format. And in CyberChef, although what might seem to be instinctive is to convert, or for me anyway, would be to convert from hex and then to decimal, since the decimal doesn't give you an option to convert from hex, this doesn't actually give you the right format. So the way that you need to do this in CyberChef is to use the base, and we say to base and do base 16 to convert to hex. The problem from base, sorry. So there again, now we don't have we have the same value it shows whenever we highlight it in ghidra, which isn't correct. So again, we just need to swap the endianness, so we'll do that here, and we get 8000. So it's connecting to port 8000 on our local host. So let's go and see what happens if we run the program with a listener set up on that port. I'll keep CyberChef open here in case we need to go back to it. Okay, so we'll set up a listener on port 8000, and then let's go and try and run the program now. And you'll see we don't get our exception abort like we did last time. And actually, if you go over to a netcat listener, we'll see that it's connected with this IRCWare 1614, and we have this join secret. So as we noted at the beginning, it was grabbing the random address. So if we run that again, we'll see that we get a different username each time. So we could try some traditional commands that we might enter. So we can try and put in a ping and see if we get back a pong, which we do. We could go and have a look then at some different commands which are available to us. I'll just go here to Wikipedia, the list of some of the IRC commands, and we could go and have a look and see what's in the program and what we might be able to use out of these. So let's go back to the code. We'll go back to the main function and have a look at our main functionality here and see what other commands that we can enter in. Remember, we have some other strings here, including these. So we have the ping, where we can send ping and pong, and receive the pong, should I say. But we can also do the private message. So what happens when we enter that? So let's take, well, first of all, let's take our priv message secret flag, because that's likely to be our end goal. So if we paste that in here, you see then we get requires password. So we can't get just straight to the, this is what we've just hit there, is the requires password, or yeah, we've hit the requires password there. So if we have a look here at the password bit as well, we could take a copy of that and let's paste that in and just say something like password. You see there we get rejected. So we need to try and work out what the password is going to be that's going to give us access to the flag. So let's go and open this up without looking too much at what the code's doing for now. Let's open this up in GDB and see if we can trace through it a little bit. So I'm going to open this up with GDB pwn debug, and because it's stripped we don't get any functions. If we check there, we could have a look with, we can open up redair from inside here as well, and that would show us the entry function, so we could at least go in there and have a look at the code. We can also put this into a visual mode, although we can't do it from inside pwn debug I don't think, but put it into a visual graph mode so that we can kind of see the looping that occurs a little bit better than we can at the moment. But let's we're going to want to set up a breakpoint, so let's go back to our code here. Let me resize this so we can see a little bit more as well, seeing as the code's not taking up too much room on that side, and then we can see our addresses here as well, although don't need that much room. Okay, so the password's being taken here. We have our jump if 0 here, so let's set up a breakpoint around here and we'll see what happens with the comparison. If we compare that to the code, it looks like we have the check down around here. But let's go, I'm going to take a copy of this and we'll take that to GDB, set up a breakpoint, and then we'll run the program. If we go over to make sure that we have our netcat server running here, which we can see that it's joined, it's assigned a nickname and stuff like that. So now we want to try and enter in a password. So we'll take a copy of this string. I'm going to paste that here and we'll just say password is HackTheBox. Hit enter, and if we go back to GDB we'll see that it's hit a breakpoint because we set a breakpoint right here at this instruction. So we can step through this then. Let's hit next to step through to the next instruction and see what we have here. I'm going to keep stepping through and see we have our HackTheBox is now in the RSI, and in the RDI we have this other string RJJ3DSCP, and let's hit next again. We have our, so now we have some comparisons. Let's go back to GDB, back to ghidra for a second. So here we can see that this is where we have our string, this string being used, the RJJ string, and then below that we have some comparison checks being done. So we have a series of checks done, and after each one it'll do a comparison and decide whether or not to jump somewhere. So it looks like that's where we are at the moment. You can see we have, well, we can verify where we are because we're at 400,405, 400,405, which is right here. So we're about to go through these comparisons now, which appears to be right down here as well. So you can see once we get down to these comparisons, it's jumped down to this loop. So we'll have a look at this loop a little bit closer shortly, but let's just go back through to GDB. We'll hit next and see what's happening with this loop. We have the comparison being done there at the moment. So at the moment it's comparing the AL register to 0xA. So let's have a look what's in the AL register. We can do PAL. Let's print it as decimal. Let's print it as hex. No, let's print it as a char. And we'll see that's the H, so that's the first letter of our password. So it's going through and it's comparing the first letter of our password to these values. We can go through next again, and it's going to be comparing the same thing. Let's have a look and see what the... So that's 13 that is being compared at the moment, and again it's still comparing it to our H. So we can keep going through here. I wonder, is it going to get to... Let's have a look and see if that's still H. Yep. Still H. I'm just wondering, is it going to, if we have the first character wrong, is it going to reject the password, or will it? Okay, so it's got through H there, and we got rejected, yeah. So if the first letter of the password we enter isn't correct, then it's not going to even bother checking the rest of the passwords. It's just going to reject us straight away. So that would potentially mean that we could brute force each character, right? We could just loop through the range of possible characters until we get it, so it's not rejected. But we'll try and do it a little bit smarter than that. One quick thing we might want to try in case the password isn't linked to the flag printing functionality is to go and have a look and see where the flag is printed. So we have the accepted right here. So if this function is being called, we might need some of the variables to be set up before the function is called. So we have these checks that are occurring, but we could go to have a look and see what's after the check. And we have the jump not zero there, so this is after the check. So we might want to just see if we can simply jump here. So we'll go back here, Control and C, and jump *0x, paste that in, and if we go and have a look at our netcat now, we can see that we have the accepted message, which looks better. I'm going to continue that. Let's go back. Okay, that instantly came up with rejected though. Let's see if we can try to submit the flag anyway, or try to request the flag function. So if we enter that in now, requires password. Okay, so that didn't work for us. So let's go and try and work out what's going on with the with the code. Whenever I did try this initially, whenever I was solving the challenge, whenever I jumped to that location, it did actually print out the flag, but it didn't print it in the correct order, so it was all jumbled up, and it wasn't even the correct character, should I say. It was encrypted. So I'm not too sure why it didn't print that time. Maybe the order of things needed to be different, but let's just go and see what's actually happening with the password that we enter and see if we can work out what the correct one is. So we know from entering in the password whenever we were running this in GDB that it's going to check the first letter that we enter. It's going to perform all of these checks, which is happening here in this loop, and then if that first letter matches up with the value that we have here, then it's going to loop through again with the next character and do the same thing. So let's see what calculations it's performing here. We can see with the if statement that we're first checking. So this is basically each character that's looping through here. It's assigning bvar4 is equal to bvar3, and then it's making sure that bvar3 is within this range. So 40 in hex, which is 64, and 5b. If we go and have a look, let's open up an ASCII lookup table. And we should know anyway that 41 in hex is capital A. You probably know that from doing pwn challenges and sending a lot of A's in. But that's running up to 5B. So it's basically running through all the capital letters here. So whenever I saw this, I essentially just looked at this first condition. So okay, if it's a capital letter, then it's going to subtract 9. So it's going to do bvar4 is equal to bvar3, which at the moment they're both the same values. And it's going to subtract 9. So if we take this value here and go to CyberChef, we can go here and we can just try and subtract subtract, oh, okay, it'll be sub then, and we can say 9 then in decimal, and that's not looking too useful. Let's try, because it's subtracting, I guess we'll need to do the reverse. Let's go back and add that instead, and we'll add decimal of 9. And this obviously doesn't give us a password, but actually this is kind of close. So let's go back and take a look at the code again and see what else is going on here. So we have that first check, which is making sure it's basically a capital letter. Then we have the second check here, which is assigning, so at the moment bvar3 and bvar4 are both equal to the same thing. They're both equal to the character that we enter. And here it's assigning bvar4 to bvar3 plus 11 in hex, which is 17, so it's adding 17 onto our character, and then it's seeing, does our character plus 17, is that greater than 5a? So if it is, then it'll perform this -9 subtraction. So the first thing that I noted here was that we have a 17, a plus 17, and then we have a -9. Add those together, we have 26, which is the number of letters in the alphabet. So without even really looking into that too much more, I threw this into a rot13. So let's, instead of subtracting 9, let's do rot13, but we're not going to rot by 13, we're going to rot by 9. So we'll go back here, we'll change this to 9, and then you'll see that we get this assembly. So nothing's happened with the 3 because it's not within the capital letter ASCII range, but essentially all that's doing here is it's doing a rot13 on the value. So all we need to do then, or sorry, not a ROT13, a ROT9. So all we need to do is take the ROT9 version of that, which is this assembly string, and then enter that as our password. So let's go and try that out. So we'll go back here, I'll just exit out of GDB for now, and let's restart our netcat listener and run the program. Okay, I'm just going to run it without GDB. And we want to first of all then enter in our password, so I'm just going to go back here and grab the command. Paste this in, and then paste in the correct password, which is assembly. We get accepted, which is awesome. So now we want to just do the same thing, but this time we're going to try and grab the flag. We paste that in, and then we get back our flag. And that has been the IRCWare challenge. Hope you've enjoyed this video. If you have any questions or comments, leave them down below. Thanks.